Hello everybody, I hope you had a good time so far in the conference. And now it's time for our workshop again, where I will be guiding you through setting up an entire end-to-end workflow or project using the Things stack. And I will cover a couple of things such as onboarding a gateway, specifically the Things indoor gateway. Then also onboarding an end device, actually two end devices. So we will do something where we will be receiving an uplink in a server application that I wrote. And also we will send a downlink from our application to the Things stack so that it can be forwarded to an end device. So I hope you're excited. Let's get starting. So the first thing that I will do is I will set up the Things indoor gateway. The process is actually quite easy with the Things indoor gateway. We can use the claim gateway functionality. So I go over here to my gateways and then click on claim gateway. Then you can see that the form is quite a lot easier than the normal gateway onboarding form, because all we have to do here is entering the gateway EUI, which I will just get real quick here. I have noted for myself already. And then you need a claim authentication code. So the gateway will be claimed and we need to authenticate this request. And the Things indoor gateway uses the password that is written on the back of the device as the Wi-Fi password. So let's go ahead and do that. And then we can just give a name, an ID to our gateway. I'll just call it TTEC workshop. And then my name. And we can select a frequency plan. As always, go for the recommended one. We're here in Europe, so we use the European 863.870 frequency plan. And that's basically, we can just click now on Claim Gateway, and you will see that you will be forwarded to the overview page of the gateway that we just created. So all that is left to do now is actually plugging it in. So I'll just use the USB-C connector, and now we have to wait a little bit. Gateway starts blinking, so it will now search for a Wi-Fi network, and then after this it will try to connect to the Things stack. Yeah, as you can see, the onboarding process for our Things indoor gateway is actually really easy. It is just 3 fields that you have to fill out, and then the process is done and you can connect it to the network. As you can see, we have a connect gateway event here. If we go to our live data panel, so the gateway has connected and already sent us some status data. So that means that we're good to go with this gateway. So it's now ready to receive uplinks and also to send downlinks. All right, speaking of uplinks and downlinks, let's make sure we onboard our first end device, the Things Industries generic node, which is a really cool device that has many different sensors, such as a motion sensor, free fall, humidity, temperature, orientation, and it also has a button. So it is a really cool device that allows you to verify your use cases in the early stages, basically with one device that does it all. And it has a lot more features, so be sure to check that out as well. Let's go ahead and onboard this one. So to do that, first of all, we need to create an application. So since this end device, this generic node is measuring, among other things, temperature and humidity, I was thinking of an app that would basically keep track of the climate in my room. So let's call the app Chauffeur Climate Tracker, and then give a nice little name, Room Climate Tracker. Create the application, there it is, and now we can actually onboard the device. So we go on Add End Device. As you might know already, the Things stack offers you to connect with the LoRaWAN device repository, which is basically a repository that contains information about a lot of devices that you can buy off the shelf. And the generic node is also a part of it, and we can use the device repository to basically take away all the work of setting up the device using the specifications and the data sheet, because all that information is already in the device repository. So let's do that indeed then, and go to the things industries right here. Then the generic node, this is the sensor edition. Hardware and firmware version is already correct, EU863870. Then again, select the recommended frequency plan. Let's go ahead and just enter the registration data. Usually if you have a generic node, the typical way to onboard it is using the claiming process. But in this particular case, for the sake of easiness and also showing you the onboarding with device repository, we chose to show you instead the manual registration. So let's go ahead and also use the app key. Enter it here. Then we can fill a antivirus ID, climate, and then go right ahead and click register antivirus. So we have done the registration now. It is already part of our application. I will just go ahead and power cycle the device now, which is usually what you need to do after you want your device to rejoin. So let me just here quickly do a power cycle. And you can see already, immediately we have a accept join request, and the device has joined already. So that was super fast, and already the device is ready to go. So I would already go to the live data and just click the button that you have on top of the generic node right here. Go ahead and tap it, and as you can see, there is an uplink coming in. You have a forward uplink data message, and you can see the data that has been transferred here, the frame payload. So obviously this is encoded. So to decode the data here, I also have a payload formatter, which is actually not yet part of the device repository. Otherwise, you would not need to do that. But I have one anyway, so we can also add it manually. So we go to the payload formatters. And here you can see you have many different ways of choosing a payload formatter. You can use the application payload formatter, you can use a custom formatter, and then you have gRPC, KN, LPP. Keep in mind that you have two layers of payload formatters. The one is on the application layer. So a payload formatter that you set on the application layer will automatically be forwarded to all end devices. So all end devices will use this payload formatter by default, unless you set a different setting, like we would do right here. But since we will also later onboard a different end device, which will use a different structure, a payload and uplink structure. In this case, we just want to use an individual end device layer payload formatter, which is what we will do now. So the payload formatter that I will set right here will only be in effect for this particular generic node that we just onboarded. So let's go ahead and delete this, and then copy out my payload formatter that I have here. And actually, one thing we can do as well, which I always like to do, is how about we just copy out the MAC payload that we just had here from our previous uplink message. Go to the payload formatters. Again, choose the custom JavaScript formatter and already put the payload that we just received here into the test byte payload. Then again, go ahead, copy out our payload formatter. And then now we can do, as we are already working with the payload formatter, as we are editing it, we can see whether the payload formatter is actually working out. So we'll go ahead and click test decoder. And as you can see, we have a decoded test payload. So there is battery voltage information, button press, humidity and temperature. And so it appears like the payload formatter is actually doing what we want. So then we can go ahead and save the changes. And now let's go back to our live data. And since we now updated the payload formatter, we can do the whole thing again. We can press the button again, which I will do now. And now you can see in the data view, you will have another forward uplink data message event, and it already contains the decoded payload in the preview here. So you can see what this translated uplink message is actually saying. So we have, again, battery voltage 2.9. We have a humidity of 37.5 currently in this recording studio, and a temperature of 23.2 degrees Celsius, so nice and cozy. So now we have an end device running on the Things stack, and of course you don't want to have it just on a Things stack. You want to do something with the data. You want to forward the data to an application that is then doing something with the data that the end devices give you. So let's do that. And of course, if we want to do that, we need an integration. So there's many ways to integrate your application with the Things stack. We have an MQTT client. We have, of course, webhooks. But then there's also some platform solutions, AWS IoT, Azure IoT Hub, and the LoRa Cloud. But for the sake of simplicity, and because it's really that simple, I like to use just webhooks because it's super simple. As you will see now, we click on Add a Webhook. And maybe just as an explanation, what does a webhook do? It's basically nothing more than a request that is being dispatched to your server that you configure that will carry the sensor data to your application so that you can use the data based on an endpoint that you set up on your application. So that is also what we will do here. We go to the custom webhook because I have a custom application, so it's not part of any platform solution. So if you have something like that, you can always use the custom webhook. So let's go ahead and again give a name. So it will be the Climate Tracker webhook. Format usually JSON, and then the base URL. So mine is actually this address. So let's go ahead. The endpoint is /webhooks. And the only other thing you need to do is set and enable the uplink message, because that's what we want. Whenever an uplink message is received by the network in our application, we want this data to be forwarded to our webhook endpoint on our application. As you can see, you can set a lot of other things here as well. So if you're interested in whether a device has joined and so on, you can also choose specific events. But in our case, we just want the uplink message. So we go ahead and add this webhook. Okay, so that is basically already it. The only thing now is my application is not actually yet running. So let's make sure that this happens now. And maybe just a few words about the application that I have. It's a really simple Node.js application. Everything it does is it exposes a server, an HTTP server, which will take the data that has been received through the webhook, and then it will display it the latest data that we received, and it will also put the data on a chart live. So whenever there's an update, the chart will be also updated live. Yeah, we have an endpoint that is waiting for requests coming in at the /webhooks endpoint. It will just take whatever it had received, and then it will push it to a variable in the memory so that we can take whatever is in the memory and display it on our website. So let's go ahead and start this one. So I have to go here. No, actually, one thing we need to do first, of course, we need to set up the application. So we'll have to go to the config file that I created. So we'll have to do two things for now. We have to enter the name of the app. So let's go back to the Things Stack console here. Go here, and here you can see this is our ID. So just copy that one out. and then go back here and paste it. Oops. Paste it here. Go down, API key, which we actually don't need yet. We can save this. We can go out and then source our new configuration. And then we can start our simple server. Let's do this. Now we can go to this address that my server is exposing. You can see it's a very simple service, just a room climate tracker. It has no data received yet, but we also have a little chart. So as soon as we have data, we will be able to plot that data on a chart. So let's see if everything works as expected. And so I will click the button again. And yes, indeed, you can see we now have a display temperature and humidity, 23 degrees and 37% humidity. So let's try and press the button again so you can see also how it will be updated on a chart. Of course, it's just 2 data points now, but over time we will have more data points. This generic node here is set up to send an update every 10 minutes. So yeah, in a bit of time, we will have some more data points, but I can also trigger an uplink just by clicking the button. So here you can see how there is more data coming in. Just once more, and then you can see there's a movement in the chart. So that works pretty simply. You saw how easy it was to set that up. But let's not stay that simple, because also I brought something else today, which is a very nice LoRaWAN device. It is the Quando Busy Light. It's a light that you can control using LoRaWAN. So it uses the Class C capabilities, and so that means that Class C devices have a continuous reception window open. You don't have to wait for an uplink and then wait for the 2 reception windows if you have a Class A device, for example. So here the device is constantly listening for downlinks, and so you can send a downlink whenever you want. So let's take this device and onboard it as well, because what I would like to show you is how you can use webhooks to not only to receive data on your server, but also to use your server to push data to the ThingStack, which is then used to schedule a downlink. First things first, we need to onboard our device. Same thing, we go to add an end device, and here's the thing. This device is currently not part of the LoRaWAN device repository. But that is also a good opportunity for me to show you how the manual onboarding works, which can also happen if you have a very new device or a device that is, for whatever reason, not part of the device repository. Then you will have to check the data sheets and then enter the information, the onboarding information, LoRaWAN information, versions, etc. You will have to add those yourself. And the console also allows you, of course, to do that. So let me show you how this works. So you go here to the manually tab, and then you will see you have a somewhat more complicated form. But don't worry, I'll walk you through it. It's actually not that it's not that hard either. So what you need to make sure is that you need to understand what is the device that we're having. So usually your manufacturer or your retailer will give you a data sheet, and the data sheet you can use it to understand what kind of a device is it, so you can onboard it manually on the ThingStack. I have this PDF here, which is the technical documentation of this device. And in there we can see LoRaWAN version and LoRaF ports, so we can go right ahead and go there. And then it's just one little sentence here saying Mac version 103, and the frame port you have to use for downlinks is the frame port 15. So that is actually all we need to know to do the onboarding here. With one exception, you also need to know, of course, that this is a Class C device, and we also need to tell the ThingStack that fact. But let's go and set the recommended frequency plan here for EU again. LoRaWAN version, we just heard 103. Regional parameters, luckily there's only one, so we don't have to know which specific revision it is. So that is also nice, it makes it a lot easier. If it would not be the case, your manufacturer or data sheet should also contain information about what regional parameters versions you need to set. Then we have just a normal OTA device, as I said before, it is class C, C for continuous. So let's set that, and then all that is left to do is, again, the registration data. So I go back to my nifty little sheet here. Oops. And then we have the dev UI, app UI, and the app key. And again, a name. So this is just the busy light. Let's go ahead and plug it in. You have to wait a little bit, of course, but I already see a join accept and a forward join message. So it seems like it has joined successfully, which is great. So let me show you another thing. As I told you, the Quando Busy Light is a Class C device, so it needs a downlink in order to be controlled. So you can send a downlink message to it and then say whether you want it RGB, which RGB values you want, and whether you want it blinking on or off. So let's do exactly that. We can go to the messaging tab in the console, downlink. We want to replace the downlink queue, F port 15, and the way the payload should be formatted is actually quite easy. You have a 4-byte, actually 5-byte array, and the first 3 bytes are for the RGB value, and then you have the 4th and 5th to control whether it is blinking or just solid. So go back and just make a payload here. So now I'm saying we want it completely white and we want it solid white, so no blinking, and this is the payload for this. So let's schedule this and let's see what happens. As you can see, it is now white, and let's do the whole thing in the other direction. Say we want to turn it off. So now we set the off time to 255 and the on time to 0. Schedule that downlink again, and you can see it is off again. So as you can see, you can use the console also to schedule downlinks directly if you want. But of course, in a normal use case, you will have some application that will take care of that based on some internal logic that you have. And that is what I want to show you now as well. So I set my app up in a way that we can also extend the configuration. Let's do that. And the first thing we will need for this is an API key. Because obviously if we have a webhook on the thing stack, you want to be sure that only you can forward downlinks to it and not anyone else. And so the request needs to be authenticated somehow. In the thing stack we use API keys. So we can go to the API keys tab here and add one. I always say this, and it's always good to say, you will want to make sure that your API keys are always as scoped as possible. So don't do just grant all current and future rights, but actually think about what rights do you actually want to give for this API key. In our case, it is just one right. It is the right downlink application traffic right. So you can create the API key, copy it out, go back to our configuration, and paste it. Second thing we need is the webhook ID. So we go back to the webhooks, and we have the ID here. Copy that one out as well, put it in here. And the last thing is the device ID, where of course the thing stack has to know to which device you want to send the downlink to. So go back, and the ID is just busy light, so we can do exactly that. And then we can save this one. and then we can source the new configuration, config env, and that's it. So now some explanation what will be happening. If you want to send downlinks using webhooks, we have a documentation page here which tells you exactly how to do that. So it also tells you to set up a API key, and then it goes to show you what endpoint you need to target for your request. And here you can see you need an application ID, the webhook ID, and the device ID. So this is why we just had to put them as a configuration to my application. And then you can use this URI to make the request and push a downlink to the queue or replace the queue if you want to do that. So going back to our application, you can now see this bit here. Whenever we receive a request on our webhook endpoint, we will check whether an API key is set and whether the right values are in the received data, so whether the button has been pressed. And if that's the case, we just do some simple logic. We compose 2 byte payloads based on whether we think the light is currently on or off, so we can toggle between button presses. And then you can see we send a simple request, which is going to the URI that I just described to you, and then it gives this data here, this payload. It just forwards the payload that we composed earlier to the body of the requests, and that is basically it. So let's try whether this is working. So we sourced it already, the new configuration, so we can just restart the application. So let's go back, restart. We will see now the data is gone again because it was only in memory. So we will press the button again. And I think you have to do it 2 times because it already thinks it is off. So I will press the button again, and then let's see whether the light turns on. Yes. As you see, we scheduled a downlink using the information of an uplink that we received earlier. So that is basically the round trip, putting data from the ThingStack to your server and then using that data to compose a downlink that you can then send to the ThingStack. So let's press again and see whether it turns off again. Yes. So that is basically the whole story. I hope you could learn a little bit from this. Make sure to write your questions in the chat. Then Nera and me will do our best to answer them. I hope you enjoyed the session. And yes, I hope you enjoy the rest of the conference and wish you the best. Thank you very much. Bye-bye.